Hello students, welcome back. Today we will continue with our chapter Physical and Chemical Changes. In the previous class we have learned about the different types of physical changes and what the physical changes look like, what are the characteristics of physical changes. In our class today we will learn about chemical changes. So let us start having a look at chemical changes. First question that will arise in our mind is, what are chemical changes? What is a chemical change? A chemical change occurs when two or more chemical substances react to form new product which have an entirely different set of properties. A chemical change is mostly irreversible. It involves change in composition and chemical properties of a substance. So chemical change, as we see here, occurs when two or more chemical substances react and it results in the formation of an entirely new product which has a different set of properties than the previous one, than the reactants. A chemical change hence is mostly irreversible. It involves a change in the composition of the substance and in the chemical properties of the substance. If you remember, in the previous video I had mentioned that physical changes do not undergo any change in composition or chemical properties and no new products are formed. But in a chemical change, new products are being formed and there is a change in composition and chemical properties of the substance. Let us have a look at some examples. Cooking food, ripening of fruit, lightening a matchstick, aging and falling of leaves, digestion of food, all of these are examples of chemical changes. When carbon, which is actually a solid substance, is burned, carbon dioxide gas is produced, which is a gas. Hence, they have different properties. Now look into the picture over here. We can see rotting of fruit, rotting of or toasting of bread, rusting of iron, burning of a matchstick, burning of a candle, and germination of seeds, formation of a new plant. All of these are different kinds of chemical changes. Now let us have a look at the next slide. The various examples of chemical changes that we will be concentrating on in this chapter are listed here. The first is we will learn about rusting of iron, burning of candle, reaction between vinegar and baking soda, burning of magnesium ribbon, and reaction between copper sulfate solution and iron. These are the various types of changes, chemical changes, that we will cover in this chapter one by one. Let us start with learning about rusting of iron. When iron objects are exposed to air and moisture, they are covered with a brown powdery layer called rust. Formation of rust on iron is called rusting of iron. Composition and properties of rust are different from that of iron, and rust cannot be converted back to iron by simple physical methods. So you must have seen, if there are iron rods or iron substances in your house, you will see that with time they develop a kind of a brownish layer on them. Why does this happen? The iron objects, when they are exposed to air, they are covered with this brown substance. The moisture and the air, the oxygen in the air, reacts with the iron, and this results in the formation of a new compound called rust. And this new compound, which is chemically different from that of iron, undergoes a chemical change. The iron undergoes a chemical change and results in formation of this rust. And the composition and properties are different than that of iron. And this rust cannot be converted to iron by simple physical methods. Hence, we now know that rusting of iron is a chemical change, because iron is undergoing a chemical change, a change in its chemical composition to form rust, and it's an irreversible change. Next, we will learn about burning of candle. Everybody in this class, I'm sure, has seen a candle burning. We all know that candles are made of wax and a cotton thread called wick. The wick is where we light the flame. When a candle burns, molten wax rises up and undergoes combustion. Combustion means the ability to burn, to form carbon dioxide and water vapor. So candle, which is basically molten wax, is rising up and forming different new products like carbon dioxide and water vapor. Hence, we can now discern that this is a chemical change. Heat and light energies are given out. When you go near a candle, you can see the light and you can also see heat coming out. It is not possible to recover burnt wax or thread. Burning of wax is chemical and irreversible. Melting of wax is physical and reversible. So look into these 2 points very well. Burning of the wax is chemical because wax on burning is producing carbon dioxide and water vapor, and it is irreversible. It's a chemical change. But melting of the wax is physical. If you take the wax again, you can melt it again. Hence it is reversible. Hence, burning of candle is a physical as well as a chemical change, and a reversible as well as an irreversible change. So take a note of this. Next, let us have a look at reaction between vinegar and baking soda. What is vinegar? Vinegar is nothing but an acid called an acetic acid which is dissolved in water. So, and baking soda is sodium bicarbonate or sodium hydrogen carbonate. See, I have written it here. So, these are the chemical formulas of these vinegar and baking soda. Let us see what is happening in this case. So, to vinegar, which is acetic acid and water, that is CH3COOH. A pinch of baking soda. Baking soda is available in your home. Acetic acid or vinegar is also available at your home. You can do it yourself with, of course, supervision by your parents and see what exactly is happening. So, in vinegar, if a pinch of baking soda is added, gas bubbles come out of the beaker. A brisk effervescence is seen. What are these gas bubbles? They are nothing but carbon dioxide. So, when acetic acid and sodium bicarbonate or sodium hydrogen carbonate react with each other, carbon dioxide is produced along with sodium acetate carbonate and water. And this carbon dioxide, which is a gas which is being formed by reaction between a liquid and solid, has absolutely new properties. So, what are we seeing? New substances are being formed and there is a change in the chemical composition, change in the properties. So this is a chemical change. How do we test that carbon dioxide is only produced? Now let us go back to class 6 and remember we had learned about an activity where the lime water turned milky when you blew carbon dioxide gas in it. The same thing we will be seeing here. So in this one particular test tube, vinegar and baking soda is mixed and it is covered with a stopper so that the carbon dioxide does not exit and oxygen or carbon dioxide from the environment doesn't enter, so that we can only see that the gas that is produced in the test tube is being tested. Now this gas is being connected to another test tube which is in connection with the help of a glass rod. In this test tube we have lime water which is calcium hydroxide. See, I have provided the equation here. These equations are very important to remember. So this calcium hydroxide upon reacting with carbon dioxide turns milky. Look into this picture that I have given. When you blow carbon dioxide or when you put this gas which is being produced by reacting vinegar and baking soda in this test tube containing lime water, it is seen that the lime water turns milky. Why is it turning milky? Now we know for a fact it is concluded that carbon dioxide gas is only produced because apart from carbon dioxide no other gas can turn the calcium hydroxide milky. Why is it turning milky? Because of the formation of a new compound called calcium carbonate, which is a solid, and that when dissolved in the water is making it appear milky. So this is also a chemical change. Carbon dioxide reacting with calcium hydroxide is giving calcium carbonate and water, and that is being seen in this test tube. Calcium carbonate solid dissolved in the liquid water, and this is giving the milky appearance. So this can be confirmed by making the gas produced pass through freshly prepared lime water. Why is it freshly prepared? Because if it is not freshly prepared lime water, the calcium hydroxide or the lime water might come in contact with the carbon dioxide in the atmosphere and turn milky. So it will not give conclusive results. So it has to be freshly prepared. The lime water turns milky when carbon dioxide is passed through it due to formation of calcium carbonate. And this is the equation. Go through these two equations very well. They are in the book as well, and remember it properly. I think we will conclude here till here, and we will continue with two more reactions in the next video along with a few more very interesting things. So if you all have any questions up till here, you can write down in the comment section. I will surely answer your queries. Till then, keep reading your chapter and have a good time. Thank you everyone. Have a nice day.